So first, before we get to the reflections, this is a throwback to Friday. So take a look, write a rule, so on the board over here I went with the red style, a rule for the following translation. Now remember, the pre-image does not have the primes on it, so you don't have yours in color, I do. Black triangle to the blue triangle, the ones with the prime. I just count. I'm gonna go from E to E prime. I have to go over 2, down 2, and specifically over to the right 2. So my rule for this, so if we're gonna go right 2, do you add or subtract 2 to x? Add, so x plus 2, and then of course we had to go down 2, got it. And that's true for all of the vertices. I just pick one. You could have done D to D prime, right 2, down 2. Same thing. Okay, let's test this guy. I'm going to write it above it. I'm afraid if I do it below, it'll be off the screen. So again, from the pre-image, mine's in black, to the image, the one with the prime in blue. So I'm going to pick a letter here. I'm going to do K to K prime. So I have to go right 3, up 5. So right 3, up 5. So it's going to be X what? And then Y. Got it. And just as a refresher, don't forget, if it asks, this is really my preferred form, the vector component form, I could have just given the numbers, okay? So just it asked for the rule, so that's why I wrote it out that long-winded style, just because of the directions. Okay, we are going to show you reflections. How to do a reflection, there's a couple different ways you can do these. I have some kids that are great visualizers and could do everything in their head and just slap down the pictures. I'm a little jealous if that's you. Others of us, like myself included sometimes, I have to use the rules that are on the purple sheet of paper I gave you that I put up on the board here that we will get into in just a minute. So what is a reflection? Let's start with that. So a reflection, first blank you have to fill in, is a transformation that uses a line like a mirror to reflect an image. And of course the mirror line of reflection. So I'm going to give you a minute to fill all that stuff in on the blanks on your notes. Now, let me explain this picture to you. Because like I said, some kids are really good once they see it, they can just mark the stuff and be done. Others of us have to use the rules. So of course mine's in blue. P is your pre-image, red P prime, the image. So a couple things we're going to notice. You're going to have this line of reflection, the line right through the middle. You're going to count the same amount from the line to each point. So if this is left 3, you go right 3. Okay? Now the other thing, this to me is the tricky part sometimes counting it, is it has to be perpendicular. Well, that's easy to do on a straight up and down line or a straight left to right horizontal line. When we get into some diagonals, it is hard for me to visualize that. So that's where these lovely formulas up on the board come into play. I don't care how you do it, as long as you can get the picture. Also notice too, if you have a point on the line of the reflection, when you reflect it, it's still on the line. So P prime, same point when you're on the line. So we're going to see all these fun-filled graphs. So here we go. So just start plotting the triangle like normal. Vertices of the triangle, A at 1, 3. And of course label, B at 5, 2. C at 3, 2, 1. Got it. Let me give you a sec to plot that. Now, here is a throwback to chapter 3. Ooh, that's been a while. What type of special line is x equals 3, horizontal or vertical? I see us going like this, vertical. Do you have to write vertical? No, but you need to remember that because the line of reflection is really important today when we graph these. So next up, I'm going to go to the x-axis to 3, I'm going to put a point, and I'm going to draw a dashed vertical line. Then a dashed. So let me give everybody a second to have their triangle and this line drawn. Because this is very simple, I just got to explain it to you. Now, as you know, I'm super lame. I always work in alphabetical order. I'm going to start with A, then I'm going to do point B, point C. So my line of reflection is the green one. That's the super important one. From A, I'm going to count straight over to the green line, perpendicular, and count how many units that is. It's 1, 2 units from the line. 2 to the left. So to reflect it, I'm going to put it 2 to the right. So 2 units to the green line, 2 units on the other direction to the right of the green line. Now I'm going to do the same for B. So my B, of course, is right here at 5, 2. I'm 2 units to right of the line. Now I go 2 units left. Now I'm going to do C. C is 1 to the left of the green line, so I go 1 to the right. And then I'm going to, of course, connect it and make the triangle. So you have to go straight to the line, so you're perpendicular, and just count how many units that is. And you do the opposite amount. That's as wild as reflections get. Okay? It's all about a counting game. So let's do another one. So you're doing the same triangle. So first things first, I'm going to redraw that original purple triangle that we had. A was at 1, 3. B was at 5, 2. And C, of course, 2, 1. So same original triangle. Oh man, I didn't draw that very straight. Work with it. Same original triangle they give you in the original direction. So plot that again. Label. Always. Now your line of reflection is different this time. They swapped you out to y equals 1. What type of special line is that? Horizontal or vertical? Horizontal. So now I'm going to go to 1 on the y-axis and put a point. And I'm going to draw a dashed horizontal line through there. Now, to reflect it. So I'm already like picturing, to me this one's a little easier to see than the first one. When I flip that over, it's going to be, of course, just flipped over that line. But instead of counting left and right, like the last one, we're counting up and down. So A, of course, right here, I'm 2 units from the green line above it. I'm going to go 2 units below. So I'm counting up and down this time since our line of reflection is horizontal. B is 1 above the green line, so I put it 1 below. Now, C prime is on it. C is on it, so is C prime. So they're the same point, which is fine. And then I'm just going to connect, make my triangle. And I can see if you flip that purple one over the green line, you land on the red one. This is as wild as it gets today, kids. A lot of counting to lines, okay? So straight to the line so you're perpendicular, count the same amount. Okay. Now, this is the one I have a hard time sometimes visualizing it. I'm going to use the rules over there. Some of you might be able to see it. So let's plot the segment. F at -1, 2. And G's at 1, 2. Now, here's the difference. You have this equation for your line of reflection. So again, throw back to chapter 3. Everything just comes back to haunt you. You're in slope-intercept form. What's the slope of that line? What's the number in front of x? 1. What's your y-intercept? 0. So this time your line of reflection, this is why I have a hard time seeing this one, is a diagonal line. We have to count to the diagonal line, which is hard for me. We have rules. So I'm going to start at 0, 0. And I'm going to count my slope, up 1 over 1, up 1 over 1. And you know my drawing skills. I'm going to put a handful of points on here, draw my dashed line. Now, I think some of you can probably look at that right now and reflect it. More power to you. I am going to look on the purple rule sheet that's up here on the board. Y equals x is on that sheet. All you have to do is reverse the ordered pairs. Okay, well I can do that. So I'm looking at F up here, F prime, I'm just going to reverse it. To make G prime, I just reverse it. So 2, 1. So I'm going to plot those. 2, -1. And then 2, 1. And now I'm like, oh, yeah, now I can see it reflected over the green line. And again, I have some kids that can count to, you can see that perpendicular part to F and then flip it. Some can do it, some can see it. If you can see it, more power to you. I have to use the rule. It's hard for me on that diagonal one. So whatever works for you. So just on the next slide and what's on your notes, are these rules. Now I'm going to be honest, I never use the top two ever because of course x-axis, I can count up and down. I don't need a rule to count how many above and how many below. I don't need it. Same on the y. I never use this rule. I can count how many to the right and then how many to the left. I don't need the rule. It's the bottom two you kind of do. So of course if your reflection line, what we just did, notice the ordered pairs just reverse. Well, that's easy enough. Now we're going to do a negative x. So not only will your ordered pairs reverse, but you're going to also negatives on them. You're going to have to change the signs. So the orders switch and the signs switch. So that's the next thing I'm going to show you. That's the last very exciting thing to all of this. So, okay, same thing. Reflect the segment over y equals negative x. So plot that original segment again. F was at -1, 2. And G was at 1, 2. So I'm just plotting that same original segment we just had. But now our line of reflection is this y equals negative x. So now our slope is changing to -1. So a little careful here when I plot this. For a -1 slope, now I'm going to go down 1, right 1, down 1, right 1. We know I can't draw, so I put a handful on here. Let's draw it. Now again, some of you can just reflect it over. If you can, I'm jealous. Okay? Now remember, f, I'm just writing it down so it's in front of us, was at -1, 2. So to make my f prime, using the rule, it's on your purple sheet, the bottom one here, reverse the ordered pair and change the signs. So I'm going to have -2, +1. Let me label that. And then G, remember, our original G was at 1, 2. So I'm going to reverse it and switch the signs. So -2, -1. So again, some of you might have just been able to see that and count it and mark it and have it. I don't care how you get that blue segment as long as you can get it on the graph. Any questions on that? Jordan?
So on the test, do we have to do the work like that, or can we just reflect it?
Most of them you can just like do it on the graph. There's maybe one that asks you to write out the points. Most of them just ask you to do the graph. All right, more of the same. Like I said, that's as exciting as it's going to get today. Let's kick it up though and do a triangle. All right, graph the triangle. Start graphing the triangle. A's at 1, 3. B, 4, 4. And C, 3, 1. Now that's the same pre-image or original triangle for both pictures. So I'm going to go ahead and while I'm at it, just mark it over here on this graph grid. I'm going to need it for this guy. A, B, C. I'm going to get myself set up here. Okay, so they want you to do over both lines. Well, it says this one first, so I'm going to start with this guy. So again, we just graphed that line, y-intercept 0. Slope -1, so down 1, right 1. Some of you can just flip that over the line and do it. Jealous if you can. I am going to use the rules. So for -x, I have to reverse the order and flip the sign. So -3, -1 for A. I'll mark them in a minute. I'm going to flip the order on B, still 4, 4. I'm going to switch the signs. And then to get C prime, reverse the order, so 1, 3, but change the signs. I'm just going to plot it and draw it. And I'm like, oh yeah, I see it flipped over that green line. Yeah, I see it reflected. I see it now. I got it. But again, it's hard for me to sometimes count it and do it, so I use the rule. However you can get the blue triangle, I'm happy. All right, so for this guy, we're doing the y equals x line. don't want to be too far ahead of you guys. So of course our slope is 0, or sorry, y-intercept is 0, slope is now positive 1, up 1, right 1. Now this is one I feel like I could do in my, just by looking at, I don't need the rule. I know I'm living on the edge here. I'm going to go out of order, I know. B. B is going to be easy. It's on the line. So if you reflect it, where's B prime still? B prime is going to be where? Same point. It's on the line. Hey, I'm crushing it. What happens if you reflect A? It turns into C. If I reflect C, it turns into A. So I'm not going to get crazier. If I flip A over the line, here it is. If I flip C over the line, there we go. So I didn't really need the rules on this one, but you totally could have. You could have just done reversing your ordered pairs, and you can see that turned into C. Reverse 4, 4. I mean, it's still 4, 4. That's why it's still on the line. And then when I reverse 3, 1, that turned into A. So that was an easy one to do without having to use the rule. As long as you can get it, I don't care how you do it. Any questions on that? Okay, quick question I have for you. Ready? Have any of the figures, have any of the pictures, any of the triangles, any of the segments changed size yet? No. So just remember our vocabulary. That is called a rigid motion. Same size is what this means. Eventually, we will change the sizes on them. Now don't forget too, sometimes we call this an isometry. You know we love our vocab here in geometry. Just a little vocab for you. Okay, the last thing I'm going to show you, we're really going to live on the edge now, kids. We're going to do a translation, left, right, up, down, and then we're going to do a reflection. Ooh. Which we call a glide reflection. First you glide it, then you reflect it. Okay, so a transformation involving a translation, up, down, left, right, followed by a reflection. And of course you're just going to do these in the order they give you. First, you're going to do your translation. So here they moved it up and to the right, and then they reflected it. That's what we're going to do. It's basically putting both sections together, 2 for the price of 1. So as always, let's start with the given. Graph your triangle there. A is at 3, 2. B at 6, 3. C at 7, 1. Now, as always have kids, what do I do first? Just do it in the order they give you the problem. I'm going to do the translation next, then I'm going to do the reflection. So you're going to have 3 triangles on your picture this time. I'm going to do the translation in red. X minus 4. So you're moving it 4 which way? 4 to the left. Are you moving it up or down at all? No, y is y, we don't add or subtract anything to it. So take your original triangle, 4 left. Here we go. 2, 3. A prime, make sure you label, of course. I'm going to do B, 4 to the left. And C, 4 to the left. Got it. Now, the red triangle I just drew, that is the one you reflect. So one triangle leads to the next. Now, x-axis. Oh, yeah, I love an x-axis reflection. I can just count. Yes, I like the counting. I don't have to use any rules, okay? It's only the slanted ones I got to use the rules on. I can count x-axis all day. So A prime is here 2 above the green, straight up and down 2 above, put it 2 below. And that is now a double prime. A little fancy notation. All right, B is 1, 2, 3 above, 3 below. And then C, of course, 1 above, 1 below. Got it. And you can see it's very easy to see. We went left 4, and then I flipped it over that green line. Jordan.
Couldn't you just do purple to blue, or do you have to show the red?
You have to show the red. It wants all 3 of them. All 3 of them. Yep. All right. Any questions on that guy? All right. Last thing is more visualization. I see people still getting their triangles wrong, so I'm just going to wait a second. So we flip the page. You can look at that lovely butterfly. All right. This is something you have to visualize. Coming at you. So symmetry. We talk a lot about line of, reflection, line of symmetry. So you can see, hopefully it copied okay, this very lovely butterfly has this line of symmetry drawn through the middle of it. If you fold it over, you fold the butterfly over that line, of course it matches up. So that's what this is telling you, line of symmetry. You can map it onto itself over a reflection line. So, visualize. How many lines of symmetry do you think each of those pictures have? You can draw them in there, mark on the picture, do whatever you want. I'm just after a total number. Think about it for a second. Okay, I'm going to do them totally out of order. I'm going to start with the easiest. How many lines of reflection does C have? 1. Now, you don't have to draw it. It doesn't ask you, but just to show you. That would be your 1 line of symmetry. I fold it over. It maps onto itself. All right, let's do A. How many do you have for A? I see 4. Everybody's 4. All right, where are the 4 lines? So hang on, I see all sorts of like hand gestures. So I see this, yes? So let's look at that. Does that work? Yes, okay. So I'm going to erase them so I don't get like crazy messy here. And then I saw this. Does that work? Yes, okay. And then I think, let me erase that. And then I think you want to go diagonal. Is it like this? Does that work? No. It's kind of, sort of, but does it work? So there are how many? 2. Okay, all right. What do you think about B? There are 6. 6 on this one. Anybody need me to draw them? Okay, because of course you can go straight up and down, straight through the middle. That's pretty common, and then kind of through the sides there halfway. You got it. That is wild.